Right, so hello, welcome to today's webinar. It's 10 o'clock here in the Netherlands. My name is Eric Nijveld, CEO and co-founder of technologycatalog.com. I'm your host for the webinar today. Today's webinar is organized together with VROC, a company specialized in industrial big data and automated machine learning technologies. Trevor, Bloch, Chief Technology and Products Officer, will present VROC's AI platform, a powerful solution to improve asset performance. But before Trevor speaks, it's first Razik Aznam who will share his experience in utilizing AI to monitor processes and equipment. And I believe this experience particularly from the days that Razik was working as Chief Operating Officer for Petronas Carigali in Turkmenistan. Before handing over to the presenters, a few practicalities. If you have any questions, please type them in the Q&A box that you see on the left-hand side, and we will go through the Q&A following the presentations. So with that, I would like to hand over to Razik for the first part. Razik, over to you.
Thank you. Thank you so much. You can hear me clearly, right?
Yes, loud and clear.
Okay, that's great. Okay, just the introduction as being mentioned just now. My name is Razik Aznam. You can just call me Razik. Currently, I'm holding the positions as a general manager for Carigali PTTEP operating company that is taking care of both Malaysia and Thailand investment in the area of joint development area between Malaysia and Thailand. And formerly was the COO of Petronas Carigali Turkmenistan, operating in the area called Kianli in the province of Tumambashi in Turkmenistan. So the sharing that I'm going to perform today is basically the experience that I have implementing AI monitoring in my upstream operations. And Petronas Carigali Turkmenistan is the second place that I implemented these AI tools called VROC. And the first one was my previous assignment as the field manager in Dulang Platforms, which is in Malaysia. So my journey towards AI, there's two. I started in Dulang Platform. And the case for change for me back then is the production deferment, which meaning that I have a very unreliable gas compressor where we call it gas compressor module number 3 in Dulang Platform. And the mean time between failures of that compressor was less than 2 weeks. So back then, when I was first joined Dulang Platform, whenever we have this compressor running for 2 weeks straight, we will be celebrating. That shows how unreliable it is. And throughout the years, it has been too many efforts of calling in all the experts in to look at the reliability to improve the reliability of the gas compressor. But unfortunately, most of the effort doesn't resolve the issues in totality. And this gas compressor is not meant for sales of our gas, as Dulang Platform is a crude or oil platform. The gas are being used for the gas lift purposes. And 90% of our, or you can say about 98 or 99% of the wells is gas lifted wells. So if the gas compressor is down, we cannot recover our oil. Thus, the importance of this gas compressor is really critical to make sure that we can get or produce our oils. And like I mentioned, that with all huge effort and huge man hours plus all of the costs on troubleshooting, still unable to resolve the reliability issues. When I joined in 2018, and I found one AI company that have zero oil and gas experience, that I wanted to try something different. I don't want people to tell me what's wrong with my compressor. I want the data to tell me what is wrong with my compressor. So that is where the first step I found VROC, and they don't know anything about gas compressor back then. Moving on, and once I settle my job in Dulang and resolve the issues in Dulang where I can speak after this, I move on to Turkmenistan, and the first AI application was introduced in Turkmenistan is because of unavailability of one of my turbine generator. So I have three number of turbine generators in Turkmenistan. The philosophy of running is two running and one standby, with a load sharing of one generator. The meaning of this is our capacity of one generator should be able to take up all the loads for the power of the whole of our complex. But due to the criticality of our gas supply, we have to run two units of generator. And due to running two units of generator, we are running at a low load of the generators. So when we have a problem with one of generator, meaning that we have only two available at that particular time, that is where some sort of paradigm shift need to be done, where we run only one generator then that can take up all the loads. But the issues right now is if this generator down, then we will have trouble with our plant. So the reliability and availability of the generator need to be 100% uptime. So due to this issue, I introduced the same concept from Dulang before, where AI can help me to predict when is my generator going to fail, so that I can understand and react accordingly, so that my plant will not be affected. Okay. The picture is over there. Dulang is on the left, and also the famous generator in Turkmenistan is on the right side. So I'm going to go with how I use AI on the day-to-day basis. On this example, I will provide to you and try to share with you is the latest one, how I predict my generator failure upfront before it trips unplanned. So as you can see on the top left, this is a high levels monitoring of the AI. So not just the generator that we predicted. We started with generator, which is the turbine generator, and then we expand to quite number of equipments where you can see that I can predict my wells, my glycol generations, my compressor, and so on and so forth. And as you can see that from the examples that shows here, the generators have a prediction that it will fail in 5.6 days. So this is the first step as the management of the Petronas Carigali Turkmenistan back then is, this is my pitch. I will look at it on day-to-day basis that I would know that what equipment going to fail. And those numbers will tell you the time to failure of that equipment. So in this particular example, the generator will fail in 5.6 days. It doesn't tell you what the causes of the failure on the main page. Then I go to step number 2, where I prioritize the activity with a high probability and high impact. As you can see on the second photo down there, there's a snapshot of my gas turbine generator. We call it GTG. So GTG number 1 is currently on offline. The problem that I mentioned before is with GTG number 2, where it is unavailable due to some issues, which is a prolonged unavailability. So the one that is running is GTG number 3, and the one that is currently on standby is GTG number 1. So when I see that this generator going to fail in 5.6 days, this is where I'm going to step in. So what is the problem and what we're going to do with it? Yeah. So this is where the second step that the engineer have to react before the management comes in and asks. Yep. Step number 3 is attending to the warnings raised by the VROC predictive models. As you can see on the first graph on top, yeah, it does mention that on the present time, 5.6 days, yeah, I can use my cursor over there, hold on. Yeah, this was on the present day where it does speak about, it does shows that 5.6 days. And this is where we have to react. And on this issue, when we look at the models, we know that it will trip on our air intake filters, the pressure, meaning that the air intake filter will start to clog up until you cannot get any air going to the turbine generator, the combustion area, and the generator will fail. So the easiest way that we're going to do this is basically when we know that it will fail in 5.6 days, what we will do is we will make sure that we turn off or manually shut down the unit. And before we shut down the unit, of course, we're going to start up our generator number 1. So generator number 1 was online. We shut down our generator number 3. That is where we can perform our maintenance over there. But as you can see that during this time, we did not react anything where this area is the GTG number 3 was in shutdown, and we start up back our generator for about, I would say, around 3 to 4 days after that. And the graph shows that it still deteriorates, meaning that during that particular time, we did not react towards the model that shows what are the things that we need to perform. So after 3.7 days, it does goes down until it triggers 1 day. Then of course it will shut down. But of course before it shut down, we react by starting up back the GTG number 3 and then clean up the filter, and then we start up back after that, then the unit starts to okay. So as you can see on the features over here, where it does mentions what are the probable causes of the unit going to shut down. So the highest probability that shows on the screen is the PDV, which is the pressure differential, PDI, pressure differential indicator, where it does indicate the differential pressure between P1 before filter and after filter. So when the filter start to clog up, this DP going to increase. So that is where you're gonna get this air intake filter DP. It goes up until a point that this indicator of time to failure on the generator will tells you how many days it will shut down. So you need to react based on that. And that is how we operate to make sure that the generator, the total power for Turkmenistan plant was not interrupted. Yeah. And where the root cause can be easily monitored, and we can straight over rectify the problems. So throughout the operations of our gas turbine generator, and this is just a model of GTG number 3, the model that shows, the parameter that shows whether it's online or it will trips is totally based on the NGP speed of the compressor, meaning that the RPM of the generator itself. So throughout the historian from 2020, you can see that the trip on air intake here is about 5 times. And when we start to implement the AI monitoring, we can start to prevent the trip from happening. When it goes up, then we react to it. whether we shut down the unit and then online the other units, and then we start to do the maintenance and so on and so forth, it will not interrupt the total power supply of our plant. So during this implementation of our AI monitoring, we did prevent 2 times of our generator sudden trip due to the air intake. And this is just the simplest example that I can give. In actuality, there is a few models of the generator that we predicted, not just on the air intake. We have on the loop oils and quite a number of the predictions. And basically, once you get the model in, the model will tell you what are the possibility or the time to failure of your generator based on the parameter that you have already set. So this is one of the case that we prevent the things. And when we implement AI, the AI monitoring, which is VROC, we did have that success of our initial mission, where we don't want the generator to sudden trip, where the plant going to be a total blackout or something like that. With only one generator running and one on standby, we never had any total plant shutdown due to power failures. And this is currently the models continue to operate today. So the beauty of this thing, it will tell you how many days, or like for example, it tells you 5.6 days. Of course, 5 is days and 0.6 is equivalent to how many hours. Yeah, you do the calculations. So as you can see that the gray area where we shut down the unit, where we run another unit, and those green that it is running, and when it shows yellow, it means that it already start to predict when it's going to fail. So this is where the engineer have to react. They have to look at the models. They have to perform the maintenance or look at whatever the probability of the root cause for it to trips. So it does, basically, it does prevent you to have a, you will not have any sudden trip on your generators or any equipments that you wanted to model in. And it will tells you what are the root cause that make that equipment trip, so that you can intervene earlier than the time for it to trip. Okay, that is example number 1. Example number 2 that I'm going to show is how AI, not to say to replace human, but it can reduce the effort of human intervention on this. This example is with regards to Dulang previously, where the gas compressor criticality that I've mentioned. When I joined in, before I get to know VROC AI, what I did is I came out with a focus group that's about 4 number of engineers, 1 operation engineer, 1 process engineer, and 2 expert on rotatings. So for 2 weeks straight, they are performing no other jobs but looking at the root causes of this gas compressor number 3 reliability. So after 2 weeks, they come up with 5 number of items that they wanted to look at that needs to be improved. When we got to know VROC AI, we push in all the data in of the not just the gas compressor, but we push in all of the data of our platform, the Dulang platforms. When I say all of the data, meaning that from wells up to sales. Yeah. So all of platform data goes into VROC AI to simulate what is the major causal of this gas compressor unreliability. And within 10 minutes, it come out with more than 20 number of root causes that you should be looking at. And true enough, when we resolve this issue, the problem is not with the gas compressor. This is where the failure of previous experts are looking at the wrong thing. When we have a problem with gas compressor, people will always look at the mechanically or the rotating parts of the gas compressor. But in actual of this root causes, when we run our AI, the highest probability of that gas compressor to trip is actually a gas line after the glycol before it enters into a gas compressor, which if you are a rotating engineer, you wouldn't know about this. So like I said, we spent about 4 number of engineers looking at it for 2 weeks straight, and AI can help us with only 10 minutes to show us more than 20 numbers of root causes that we should be looking at to improve our gas compressor. So the results from our effort, which is the focus group just now with the 4 engineers, plus with the help of AI, we improve the uptime of our gas compressor. As you can see from the graph here, it shows that the total running hours of our gas compressor. So, and before the implementation of our improvement efforts, the graph shows that a low reliability, it can go up to less than 300 hours per month. And then our first VROC model proof of concept was done in May. And in July, we implement we call it needle and stone action. And from there, you look at the improvement, which is very good. The uptime of our gas compressor improved a lot. You minus the Dulang Oktoberfest here. Oktoberfest is just a name. It's actually a turnaround. And also Dulang TA is over here. But in totality, the running hours of our gas compressor improved a lot. And with this, when we look at the total number of improvement, it's about 744 hours, and this is only about few months. And we did share with our management that due to this improvement, we managed to get our value of loss avoidance based on oil price $70 back then. It was $21.7 million. The third case that I'm going to share is something not related to equipments, but this is one of a magic that we get. I call it LOPC avoidance. LOPC stands for loss of primary containment. It means leakages. Yeah. So you don't want any leaks at your platforms, which is a risk or a threat towards HSE. The story was for Dulang, we cannot sell our gas because of our gas is very high in CO2. It's about 80% CO2, and that is where we use the gas to become our gas lift for gas lift purposes. So due to high CO2 in our gas, one of the parameters that we are really critical that we have to take care of is the level of moisture in our pipes. So whenever we have a high moisture, when you have a moisture in CO2, liquefied CO2, meaning that a high corrosion that will happen. So that is where we don't want to have high moisture in our gas stream. So we created this corrosion operating procedure where we need to comply with. In any case of moisture goes high, we only have about 3 days to react. And after 3 days, if our moisture is still high, then we have to total shut down the platforms. And this is the operating procedures have been made known up to the highest level of our management. So on this particular occasions, we saw that one of the tag, which is the moisture analyzer tag, keep on giving us a high readings on our moisture for about more than 200 or 300 ppmv. So back then we tried to resolve what is the issue with our moisture, and we try to calibrate the moisture analyzer, but it fails. It's still showing the high number of moisture in our systems. So what we did is we just run VROC AI on this. We just take one tag, which is the moisture analyzer, and what are the causes that makes this moisture analyzer to goes up. And it came to our surprise, if you look at the probability over here, the predictions on why does the moisture analyzer increases, most of the tags mention about the moisture analyzer itself. But there's one tag that really puzzles us. This tag represents our gas lift. Yeah, one of our wells is actually one of our gas lifted well. And this well by the name of B24, stand for Dulang B, well number 24. We thought this is just an error coming from the AI, where it doesn't make sense. Why does this well have to do with the rest of the moisture? So, like I mentioned before, our timeline is only about 3 days. And before the 3 days, I make that decision saying that just shut in this well. I don't know what happens to this, but AI pick up this. There's something wrong with this well. I'm not sure what it is, but shut in the well first. Straight away after we shut in the wells, the moisture goes down, half of the value. If you think logically, it doesn't make sense at all. Well, back then, I do not care about whether it makes sense, whether it's logical, but I want the results. By shutting in this B24, I get the moisture to goes from 243 to 144, which is half of the value, which is great enough. And then you make that investigations whether what's wrong with this well. So when they make that investigation back then, they found out that this is a high gas oil ratio well, and we shouldn't, there's a problem with one of our choke valve that controlling our gas lift that going into that well that created a high gas into the gas lift for this B24, and it like circulating and not performing by itself. It's not lifting the wells. So due to this, we did avoid a value loss of shutting down the platform for about 1 day to rectify the problem, and the value loss avoidance we calculated around 1.12 million. So this is one of the magics about AI. It will tell you something that you wouldn't know, although you think that it's not logical. This will be my last slide. The ongoing and also future business benefits. 95% of our use is basically for time to failure prediction on my equipments, and 5% used for flaring reduction. The future target of this, and I'm talking about Turkmenistan operations, they are looking at corrosion monitoring and LOPC reductions, maximizing well technical potentials. They are looking at how to optimize their operational chemicals. And last but not least, the flaring and emission reductions. So all of this can be made with AI, where it tells you what you should be looking at. And then as a human, you would react to it. And that is how we can operate together with AI. So thank you so much.
Thank you very much, Razik, for the great presentation. We're now going to give the floor to Trevor.
Okay, perfect. Thank you. So great. So now that Razik has gone through some cases of AI in action, and we can see that there are measurable savings to be made, I'd like to give you an overview of VROC and where this technology is heading for us. So what is VROC AI? So VROC, we started as an engineering company about 30 years ago, looking at heavy industrial equipment, offshore oil and gas, mining, power, utilities. And about 10 years ago, VROC was spun out to provide AI and analytic solutions to our customers. So our engineering background as a company is over 30 years. And in the past 10 years, we've been using our experience to deploy predictive maintenance and industrial AI solutions. And you can sort of see our footprint on this map here, the sort of regions that we cover. And our customers include asset owners and service providers throughout a number of industries, including renewables, oil and gas, mining, energy and utilities, smart cities, marine, agriculture, and process industries. And so what I'd like to go through now in the next few minutes is just to show you where we're heading and where we're seeing a lot of our customers heading with this sort of technology. So I guess a lot of this technology is now quite commoditized. So deploying it, scaling it is no longer a huge cost and a big project you have to do. It's really easy and cost effective to get these solutions up and running off the ground and getting returns really quickly. And I guess if you have a look at I guess some of the cases that Razik was talking about, you can sort of see how asset management is improved and optimized by using this technology. So when the asset management or operations personnel come in the morning, they can immediately see how their facilities are performing and what areas they need to focus on. You can see Razik was showing us the traffic light view, but we also do a sort of a risk matrix view, which you can see at the bottom left there, which shows you the probability of failures as well as their impact, because for some equipment, although the probability of failure is high, if the impact is low, maybe it's not such an important thing. We need to look at things that have a high impact on our operations. So we prioritize activities with high probability and high impact. We implement the work, and then because we're pulling in real-time data, once the work has been completed, you can have a look at the dashboards. Once the equipment starts running, we can confirm that the repairs have been conducted successfully and the equipment is now running correctly. But I guess this is at a plant level. What we're seeing a lot of our customers, I mean, obviously in these sort of industries, our customers generally have more than one asset. They have a large number of offshore oil and gas assets. They might have offshore wind. They might have solar. They've got a variety of assets that they're managing. And a lot of them are now, instead of having individual SMEs and engineers at each site, they're trying to consolidate these into operations centers where we can manage a number of different sites from one team of engineers or SMEs. And so bringing that data back to a central location is important, but also being able to prioritize that work. So if we've got a team of SMEs and we're managing 10 or 15 sites, what is the most important job that this team needs to work on at the moment? And so AI can help us in that respect, because not only do we know when things are going to fail and what's going to fail and potentially the root cause, but we also know what the expected effect on our production is going to be. And so for companies that might have KPIs that they're trying to meet, we're able to link those KPIs with the tasks that need to be performed, so that the tasks that have the biggest impact on our company KPIs are executed first, and then the other tasks are executed in priority order. And I guess what we're trying to do with this is align, I guess, management's expectations or the company's expectations to maintain KPIs, because these are the things that are important to the company, with the work that the engineers and SMEs are actually doing. So rather than doing the things that they enjoy, they do the things that mostly affect the KPIs, which is what the company deems as important. So that's what we're trying to do with this technology: bring all that data together, allow centralized operations, but then allow all of the work to be prioritized to meet the company's goals. And again, similar to what we saw on the previous slides, instead of looking at a single facility, now we're looking across a portfolio of assets or portfolio of facilities that might be offshore, might be wind. They don't actually have to be the same type of facility. We can still provide KPIs across disparate assets. So now the engineers in the operations center are saying, how are my facilities performing today? What's my top priority amongst all of the different things coming from all my facilities? They can prioritize again across their whole asset base. What are the things with high probability and high impact? And they can schedule and mobilize work for personnel to go out and visit those sites to perform the repairs. Again, once the repairs are completed, we get live data coming back. The AI can monitor the outcome and confirm that the repairs were completed before they sign off their work order. If repairs aren't completed, they can then send the maintenance personnel out again to perform further work on those assets. And the value realization from this way of operating is quite significant. We don't often get hard numbers from a lot of our customers, but if we look at this, this is from a offshore platform in the North Sea. This is a late life asset. So this asset only had 3 to 5 years remaining before it was being decommissioned. And what we're seeing here in the graph, I'll just see if I can move my mouse across. What we're seeing here on the graph is their production losses. So normally we would say these losses are deferred losses, but in this case, because the asset only had a few years to run, these are actual losses because there's going to be no more time to pull that oil out. So we can see here the losses, 300, 400, 500,000 pounds per month for unplanned shutdowns. And in the green area on the right, we can see the difference when AI monitoring was implemented. So we can see the production losses go down to almost zero for all the time that the AI was running. And we can see in July, we have a negative dip here. And this is actually an optimization that was suggested by the AI that they implemented, and it actually saved them, or they produced more oil than they thought they would. So there's a significant difference between before and after the AI implementation. Here are a few more numbers. Again, 83%, that's the one that we just saw. Southeast Asian operator saved 24 million. They also increased their reliability from 60 to 100%, and improved their flaring compliance from 50 to 100%. So we can see that there are measurable benefits to applying this technology. It's now mature and proven in the field. So this has been around for, as I said, almost 10 years now. And again, it is somewhat commoditized. So where there was initially a large upfront cost to get it started, now that's completely gone, and there's a very low bar to actually get this technology off the ground. And these solutions are also built now to rapidly scale. So rather than taking a long time to gain your ROI, these solutions can recoup their ROI in less than 12 months in most cases. So I hope this presentation has been informative and interesting. We do have a few minutes for any questions you may have, so happy for you to send them through now in the chat, and we'd be happy to answer them for you.
Hey, excellent, a great presentation. So clearly articulated value, and we have quite a number of questions already. Actually, quite a number of questions related to data quality. Can you say a couple of words about it? Say, what type of data quality do you need? And does it, for example, require cleaning of the data before the AI application can run?
Yeah, good question. So in most cases, if you're running an offshore oil and gas platform, you need to have sufficient data just to make sure that the platform is safe. So for most offshore oil and gas platforms, the data that you're already capturing is sufficient. I know in Razik's example, for the Dulang one, there was a data cleanup exercise that was executed at the very start of the project. And that was more just to make sure that the root cause analysis was correct, that all the sensors that we thought were measuring something were the actual ones, because there were some mixed up sensors that were, a temperature sensor was labeled as a pressure transmitter, for example. So there was a cleanup exercise for basically so that the results made sense. But really, from an AI perspective, the AI is happy to work as long as the sensor responds to some environmental change. So if the temperature goes up when it gets hotter, it doesn't really matter what that number is. The AI just needs to look for that change. And so the AI is taking the data from all of your sensors and trying to build correlations between all of them. So if you have some sensors that don't work, the AI is going to exclude that sensor from the AI model. Whenever we do produce AI models, they always provide a confidence level. So if the confidence level is high, 80 or 90%, then we know the model's okay. If the confidence level is too low, then it's either that we don't have the correct sensors to be able to model that process, because obviously for some processes you need specific sensors and specific data, or the sensors that we do have are not serviceable. But generally what we find for oil and gas offshore, the data that you're already collecting is plenty, it's clean enough, and it will provide enough information for the AI model to be successful.
Excellent. And I think what you also just mentioned is when conditions evolve over time, the model continues to run accurately. Is that correct?
Yeah, correct. So these models are not static. Obviously they get trained with the historical data, but as new data comes through in real time, they're adjusted and they're updated. So if you're running the plant in a new operating mode, the AI will learn that. If there's a change in the gas or a change in the weather, the AI will understand that and incorporate that into the model. So they get more intelligent and more accurate over time. That's correct.
Excellent. Hey, question to Razik. How long did it take from the initial contact with the VROC team to implementation?
I started with a proof of concept first, where I'm trying to get a AI company that have zero experience in oil and gas, try to predict what is the causes of my compressor. That is where the gas compressor model number 3 happens. And based on the previous question also, back then we did not have any of our data to be cleaned up. And the confidence level of the AI model is only about 50+%. And although that 50+% can give us a quite accurate number of root causes that we can have. But throughout once we get that POC done, where we saw that the benefits of having this AI monitoring, that is where the commercial models goes on and so on. And then we started with cleansing our data until we get the first model of our prediction. It took us about 3 months or 4 months, and this particular timeline is only for us to clean up our data. But if your data is good enough, which is highly unlikely, then you can create this within a day or two.
Okay, so the actual implementation is very fast. It may take some time to do the vendor registration, get the PO out, but once that's done, it's relatively fast. It's very fast, actually. Is that also your experience, Trevor, working for other operators?
Yeah, I mean, the actual implementation is fast. Getting approvals to get us data, pulling historical data, that usually takes 99% of the time, I would say. Some operators we've spent 8 or 9 months just getting the IT approval tick form signed so that we get access to the data. So the actual implementation is very quick. As Razik said, once we've got the data, it might just even be a few days for us to get the AI models up and running and the system providing insights. It's that prep work of getting access to the data and getting the approvals that usually takes the time.
Yeah, excellent. Hey, another question for you, Razik. Can you say something about the organizational challenges during adoption? So in terms of skills, culture, or data access?
Okay. This is actually the biggest challenge in implementing AI monitoring, actually. Where previously back in 2017-18, AI was still a baby. There is no ChatGPT, so most of the belief is coming from AI would definitely gonna replace the manpower. And one of the case that we built in, it's the one that I mentioned that is illogical, that when you have a high moisture and it goes to shutting a well, so it doesn't make sense. So back then it's like quite tough for us to change the culture in believing that AI can help us to straight away looking at the specific pain points that we are having. So the organization change or a culture change is really needed if those organizations wanted to implement this, as you need to have those engineers to work on the predictions and to tell our frontliners, which is the technicians level, what they have to do. You cannot expect that the technicians would definitely gonna look at the prediction models and do their own models and thus work by its own. Engineer have to work as a brain of this, and you will tell them what they need to do. So definitely some culture change, and if you can have the organization change, it would be even better.
Yeah, excellent. Hey, we're reaching the end of this webinar. I do see multiple more questions in the Q&A box. However, in interest of time, we can close the webinar now. However, if you do have questions, please reach out to the VROC team. This webinar is recorded, and all people that registered will receive a link to the recording. So many thanks to the presenters. Very insightful presentation. Great examples of how impact can be realized as a result of technology deployment. Actually, before closing the call, I would like to highlight that we have another webinar next week. I'm actually going to be the presenter next week. I'm going to share best practices for building a technology plan and how to get the technology deployed. So the webinar is going to take place on the 2nd of December at 10 o'clock Central European time. But with that, yeah, many thanks again to Razik and Trevor, and many thanks to all the people that attended the call today. And I wish you all a great rest of the day or a great evening. Bye for now.
Thank you, Eric. Thank you.